So let's look at some questions that involve the standard normal distribution. So this is coming into play from all of these normal distributions. You could have a normal distribution with any mean and any standard deviation. What we're trying to do here is make things a little easier on ourselves by having a single normal distribution that we can talk about. And so if you think about, we're allowed to choose any average we want and any standard deviation. What would make things easiest on us? Well, the nice thing about choosing an average of 0 is that it makes the distribution symmetrical around 0. So +1 and -1 would be an equal distance here away from the 0. And the standard deviation we choose to be distance of 1, just because, again, that's probably the cleanest. You couldn't really choose a 0 for standard deviation also, or you wouldn't have any distribution here at all. So it makes sense to choose one of 1. It's the simplest number other than 0. And this data here is the empirical rule, but what happens when we want to know a question like, for example, how much of the data is this line halfway between the -1 and the -2 all the way out to the left? How much data would be in that little chunk of a normal distribution? And so these right here are called z-scores, these numbers that you see, and it really just means how many standard deviations are you above the mean. So if you're negative here, that means you're actually below the mean, and anything to the right side of this would be above the mean. So half of the data is below the mean, half the data is above the mean. And we have this table, or this series of tables, that can help us convert in between two things, and it helps if you think of this as a conversion. So we're converting between a z-score, which is a specific spot along this x-axis, and the percent of the data that's to the left of that z-score. For example, a z-score of 0 would have 50% of the data to the left of it. But what if it's not such a nice number? Let's take a look at this. What if we had a number up here like, say, 2.2? We had a z-score of 2.2, and we want to know what portion of the data is below that z-score of 2.2. We could use these empirical rule numbers for an estimate, but if we want more precise, that's when we come to this table. So these things on the edges are z-scores. These give you the units placed to the left of the decimal, and then the tenths to the right of the decimal. The column gives you the hundredths, so that would give you 2 places to the right of the decimal. And we said, I think, 2.2. If we would scroll down here and look at 2.2, and then our hundredths would be a 0, that would put us right here. What that number right there tells us is that 0.9861, or if we convert it to a percent, 98.61% of the data would have a z-score below 2.2. In a normal distribution, 98.61% of the data would have a z-score less than this. What if we said something even more specific, like 2.24? Well, again, we'd go to the 2.2, scroll over here until we're in the column that ends in 4. That gives us 2.24, and that would tell us 98.75% of the data is to the left of a z-score of 2.24. What if we needed to go to the negative? So say -1.25, for example, -1.25, and we want to know what portion of the data is to the left of a z-score of -1.25. Well, these values here are all positive, and they're not going to help us. So we need to select something else. Instead of going -infinity to -z, we need -infinity to z. So if we pull that up, I think I clicked on that. Let's try that again. Or sorry, -infinity to -z. What did I say? Sorry. -1.25. So we would go down to -1.2 and over here till we get to the 5. So that would tell us that 1056. That's the portion of the data, or we convert that to a percent, which would be 10.56% of the data would be below a z-score of -1.25. So what's this other deal here where we say area 0 to z? Well, let's go back and look at that. What did we say? 2.24. We had asked what portion of the data is completely below 2.24. So it includes this entire chunk of data. And that's where we use negative infinity to z. But now, if we just wanted to know what portion was in between 0, so the mean, and 2.24, we could use this table. So we just find 2.24, and we'd get 48.75% of the data is in between a z-score of 0 and a z-score of 2.24, which makes sense because to the left of the mean would be another 50%, and if we added that 50% to the 48.75%, that would give us 98.75%, like we found when we directly looked it up on the negative infinity to z table. So this is just a conversion in between how far we are in our z-score and what portion of the data is to the left of it. Now, we could also go the other way. Let's say we know the portion of the data, but we don't know what the z-score is. And that's what this question here says. It says 0.03 of the area lies to the left of z. In other words, 3% of the area lies to the left of z. So we're trying to find this z-score, probably somewhere way down here, because we only have 3% of the data to the left of whatever that z-score is. So now we would be, we want to pull up either the negative infinity to z or to negative z, depending on if we're to the left or right of the mean. But here, since we know we only have 3% to the left, it's probably going to be in here. So we're looking for 0.03 in this chart, and we're not going to find it exactly, but we're going to be able to get pretty close. So it's in between these two numbers right here. So in other words, we're in between a z-score of -1.89 and -1.88. And it looks like we're closer to the -1.88. So we would type this in, -1.88 as our answer, submit that, and that should be a correct answer. Okay, this one looks very similar. Again, we're looking at 0.05 or 5% of the area, but notice this lies to the right of z. The previous question said to the left of z, so we had this cutoff with only, I think it was 3% to the left of z. But now we want only 5% to the right of z. So we're somewhere way out here where there's only 5% left in the tail, and the other 95% is sitting to the left of us. And that's the key, realizing that 5% going to the right of us is the same as 95% going to the left of us. Those two numbers should add up to 100%. Lets us look up the area to the left. The tables are going to give us the area to the left, or it's going to convert in between areas to the left and the z-score. So we need to look up 0.95 on the table, because that's the area to the left instead of the area to the right. So how did we get that? You can subtract directly from 1. 1 minus this will give us the area to the left of z. 0.05 to the right. 1 minus this gives us the area to the left, so 0.95. Because I know I'm over here on the right half, I'm going to jump straight to this normal table. If you would jump here and look for 0.95, you just wouldn't find it, and then you'd probably realize you need to go over here. Don't use this if it's asking for an entire area to the left or right. That would be incorrect because it's not accounting for this portion to the left of the mean. So here I'm going to go straight to this. I'm going to look for 0.95 because I know an area and I want a z-score. I'm going to be looking in this portion of the chart and then trying to figure out what z-score that gives me. So I'm looking for 0.95, and I notice it's in between these two numbers, so that would be in between a z-score of 1.64 and 1.65. And in this case, I'm halfway in between them, so it really doesn't matter what I put. I'm going to put 1.64, and that should give me the correct answer.